Welcome to Scientific Notation.
Yeah, that was perfect. That was so perfect. It is scientific notation. So, ladies and gentlemen, let's talk about this. Scientific notation is one of those things that you can actually use.
What?
Whoa.
Oh yeah, it's
Inconceivable.
inconceivable. Anyways, so
No, this is algebra.
I know it's weird that you're going to use anything from this class. Anyways, so yeah, this is actually going to be usable now. If you are going into anything to do with engineering, anything in the medical field, anything in the applied sciences, you're going to be using this, and this is, as she said, scientific notation. So what this is really good at, this is good at measuring really, really big things and really itty bitty little small things. This big.
Like my
This big.
self-esteem.
Can you try for some positivity today, buddy? I know it's 8th grade.
It's like 5 things.
He has to say 3 nice things about himself. I'll pause. Please hold. Okay, so let's talk about this. Scientific notation, as I said, is really good at really, really big things and really, really small things. Now what this looks like, a single digit number times 10 to the number. Okay? Now, unfortunately, the scientists got involved. We know this because the first word is scientific. And what they did was they took this beautiful, pure, excellent mathematics that was all beautiful and awesome, and then they decided to just, they're using an X for multiplication. This is the only time that we do this, and it's ugly, and we can't use dots in scientific notation because it's scientific notation, and it's upsetting, and I don't understand it, and it's really, I don't even get it. Anyways.
What's the second grade we use? Okay, X's.
Yeah, second grade. Second grade we used X's.
And third
And fourth,
fifth.
fifth.
Yeah, but then we started actually doing like algebra and we used dots.
I love dots.
No.
Only grade
Anyways.
I've ever used dots.
So what we're looking for here, this first thing has to be a single digit in the ones place. So you can have from 1 to like 9.9 repeating. You have to have times 10 to the thing. Now this thing, this is important. If it's positive, it's big. Am I still on camera? Yep. If it's negative, it's small. Wow, she's putting it in a box. That must be important.
What if it's 1?
You'll see.
Is that times 10 or x 10?
Times 10.
What's like after the times 10? Like you got a line and the squiggly.
Oh, these are just quotation marks. Like you have to have the times 10 to the thing.
To the power.
To the thing.
To the thing. Yep.
To the power of that. No.
Yeah, to the thing.
Yeah.
This is super fun. I feel like my lighting isn't very good. Like.
This room
Well, we
just
don't-
straight up doesn't have any good light.
Yeah, we don't have any.
Well, no, I mean,
lights on.
Okay, so now I'm going to ask you guys, is this in scientific notation? So let's look at 46 times 10 to the 14th. Is this in scientific notation?
No.
No, this is not Sinon.
Because it's wrong. What?
Because it's wrong.
Got more than 1 digit.
What about 4.6 times 10 to the negative 14th?
Yes.
Yes, this is Sinon. Congratulations.
But it's small.
Yeah, it real small. Not just small, it's
It's
small.
small.
It's so small. Anyways,
That's not
anyways,
She
you guys
turns
ready to
out-
keep going?
She turns
Yeah.
around, you want to bet?
All right. So let's say we have
That's a big number.
yeah. 8 comma 1 2 3 4 5 6 8 9 7 8 9.
That's billion.
0.17. Now, do I have a volunteer that I'm going to make fun of?
Yes, I got you.
Okay, let's talk about Ian. Ian, you look fly with your bow tie.
I don't know.
All right, so let's talk about Ian. Now, Ian got money. Ian B. Bank. Hey, Ian. So much money. Ian not only has money, Ian has $8,123,456,789.17.
I have a wonder.
So So let's think about this. Now, when Ian comes into class, he obviously gonna flex about how much money he got, if he got that much, right? Like, he gonna flex. Now, let's think about this. Does Ian need to say $8,123,456,789.17? Does he need to say that?
Yes. Yes.
It's a
No.
tongue twister.
He says 8 bands.
No, that's a weird flex, y'all. It's a
Weird
real,
flex, but okay.
yeah, it's a real weird flex. Why doesn't he just round that?
8 bands. 8 unusual boats for last.
Okay.
So we don't really care about all of those digits. So what we can do instead is we could just say he's got like $8 billion, right? He is like $8 billion. Yeah?
Yeah.
But instead, why don't we convert this into scientific notation? So this is gonna be really, really easy for you guys. You guys ready?
Yeah.
Okay. Now I want this to have digit times 10 to the something. Now we are gonna Blue's Clues this. Okay, that means we're all gonna count out loud and together with a heaping dose of false enthusiasm. You guys ready?
Yes.
Yeah.
I'm sorry, a heaping dose of false enthusiasm.
Yes. Let's go.
All right, you guys ready?
Yeah.
1,
2, 3, 4, 5, 6, 7, 8, 9, 10.
That's nice. Okay, so we made 9 jumps, and I have 8.123. This is now in scientific notation.
Oh.
Yay.
Swiper, no swiping.
I know those words.
Yes.
How did you know to put 1, 2, 3? Do you just put the, or how did you know to put
So-
only 3?
So let's think about this for just a hot second. Typically we would put like roughly 3 digits. We're not gonna put all of the digits because we don't care about all of the digits. We're gonna put roughly the first 3. Now you could choose to leave the first 1, 2, 3, or 4, and that would all be acceptable. Now, if for instance I had 8, 1, 2, 6, 7, 8, 9, 1, 2, 3.17. Okay. I could say that this is 8.12 times 10 to the 9th. I could say that this is 8.13 times 10 to the 9th. It kind of depends on your rounding. Okay? Because some people choose to truncate, i.e. just cut it off. Other people choose to round. It kind of depends on what you're doing because there's a time for truncating and there's a time for rounding. So for instance, if I was a manufacturer of seat upholstery for Toyota, well, my tolerances, the range that I need to get would be like within a 1/4 inch. If I'm engineering like a space station,
Everything has
I
to
know
be
that
exact.
word.
then you want to be more accurate. So it kind of depends on what you're doing, when, where, and why. Now, personally, I don't really care. If you want to truncate it versus round it, I personally don't care. Okay? But if you have the option, I want at least 2 to 3 digits here behind the decimal place. That's me. And part of that is because by the time your rounding could end up damaging someone, you will have had another 8 professors and or teachers. Because in some cases, rounding can lead to death.
What?
Right? Like if you are engineering a spacecraft and you engineer it badly, that could result in something going very, very wrong. So, but here's the thing. Your professors are going to tell you, like, hey, if you're working in this area, this is what we're looking for. You get on-the-job training. They're not going to throw out a first year and be like, here you go. And, right? There's going to be some oversight. So that's why I'm not particularly worried about it, if that makes sense.
Yeah.
Okay, cool. So you guys ready to keep going?
Yeah.
Yes.
Okay. Let's do 0.0000972. All right, put that in scientific notation. Now, just so that you guys know, these are called standard notation. Because it's standard.
Huh?
Yeah, they're standard numbers. That's why that's called standard notation. I need a different pen. Y'all ready? .0000972. Luke, what is this?
Um,
Do you want help?
yeah.
Okay, yeah, because I'm kind of realizing that I just kind of threw you out in the deep end. Okay, so I'm going to count here. You guys ready?
Yeah.
1,
2, 3, 4, 5.
So I know I'm going to have times 10 to the -5 because this be small. This be real small. And then I'm going to put 9.72 and I'm done
Why do we do 5?
because I had to jump 5 times.
How do you know when to stop?
Oh, you
Because the decimal is now behind 1 digit. Cool?
Do you always multiply by 10?
Always. The reason for that is because our number system is called base 10, which means we are based off of tens.
What about base 30?
Base 30 was, I believe, ancient Egypt. Base 60 is ancient Mesopotamia, and our time is still base 60 because there's 60 seconds in a minute, 60 minutes in an hour. It's really inconvenient that we jump back and forth, but you know, yeah. Well, I think it's actually not 24, it's 23.8, something like that. Yeah, that's why we have to have a,
23.56, I believe.
yeah, it's some kind of garbage number like that. Anyways, space. Anyways, cool. Do you guys need another example of these two?
Yes.
Okay. So let's do point 1, 2, 3, 4, 5, 6, 9, 5. And we're gonna do 9, 8, 7, 6, 5, 4. Nope. Ending at 4.
No.
No. You have to have one number.
You do it until there's
Raise your hand. Raise your hand.
How did you get to 5? Like, I don't know.
Here's where my decimal was. Here's where I want it to go. 1, 2, 3, 4, 5.
Why can't it go just...
Because I want I wanted something in the singles digit space place. That's a very elementary school thing. I can't really think of how to phrase it because I don't. I'm not sure if I
What?
teach elementary school. Yep.
Oh, couldn't it be 9.8?
Am I mentally slow?
Yeah, you could put 9.88. I would accept that as well. You could put 9.876. You could put 9.877. Anywhere around there, we're good. Okay, let's do computations, shall we? 3 times 10 to the 5th times 2 times 10 to the 7th.
It's on the one of the homeworks.
It was literally, look at them. It's already up there.
Can you hand me that?
Oh, wait, no, that's 3x.
So this is 6 times 10 to the 12th.
I wonder where we saw that earlier.
Are you really confused or are you sarcasming?
I'm sarcasm.
Oh yeah.
I'm not.
Yeah. Yeah, what's your question?
Well, funny, huh?
Never mind.
Huh. What do you think I did here?
This
Great.
huge property.
I did not do the distributive property.
I was wrong.
Yeah, Jack.
You added the exponents and the regular number. I don't recall that.
Integers?
Oh.
Yeah.
I multiplied them, right? So I multiplied the 3 and the 2, and then I added the exponents. Oh my gosh, it's almost like we did this before. It's the same thing.
Yeah.
Exponents never die. Woo! Much to my horror. Cool, you guys ready to keep going?
Yeah.
Duh.
Really loud.
3 times 10 to the 5th times 6 times 10 to the, well, why not? Go, 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 go! So if I look at this, I multiplied 3 times 6 and then I got 18. I added 5 plus 12, which got me 17. Why does this feel so wrong?
Because there's 2 digits.
Because what?
There's 2 digits.
There's
Oh,
2
one.
digits. 18 is not scientific notation. So I need to fix this. So what I'm going to think about is I'm going to think about a set of scales. What goes up must go down. Wow, is it fun? This is a lot of fun. Okay, so here's the deal. This number's too big, so I'm going to drop it. So I'm going to move that decimal place by 1. So this needs to go up by 1. So 1.8 times 10 to the 18th.
Let's go. Let's go.
Word.
I didn't even do the first one.
Like,
Let's do another one.
Yes.
This is a great video of me erasing. Please note my far superior technique of erasing. I've really practiced my erasing. It's about perfect. About. There's always room for more perfection.
You practice it
Oh,
for
thanks.
6 hours a day.
All right, let's do another one. Mm,
She's the hardest thing you could possibly do.
Garbage division.
all right.
Oh, I really wish I had grabbed my calculator.
Man, you know what'd be really nice? Not doing math. That would be so nice to not do math, wouldn't it?
Yeah.
Gosh, you know what's better than doing math?
It's not doing math.
Not doing math and letting my calculator do all the work for me.
that would be epic.
About that.
I love using my calculator because, man, I'm a lazy dog. We should type this into our calculator. What do you guys think?
Yeah.
What's great is I already see people typing it into their calculator, and I haven't told them how to do it in scientific notation yet. Cool, let's do this. All right, now I'm going to show you exactly how to type this into your calculator. So I'm going to type 9.7, second comma, that's above 7, 14. I'm going to put divide sign, 9, second comma, 6.
What is comma? Shouldn't it be
What?
an E when you do it?
So what's going to happen is after I hit the button's second comma, I'm going to get 2.7 E14 divided by 9 E6. And what E stands for is times 10 to the. So type this into your calculator. Hopefully someone in the front row will have it. That way I can just snatch their calculator and show off.
What did you get?
Go into the darkness to retrieve a calculator.
I did it without the calculator.
Ooh. Did it without the calculator. We're so proud to enter.
She's not really proud.
That's wrong.
Yeah, you're wrong.
I got 30 billion.
All right, we got 3 with a whole bunch of zeros.
Yep.
How many zeros did I get?
Too many.
2.
7.
I about fell and died.
Students need to report
I was
to
worried.
Jagger Hensley, Justin Pickett, Gabe Crouch. Thank you.
Oh my God. No, you got 8, didn't you?
7.
You have to pause that every time that happens.
I was gonna try, but I don't think I made it. 3, and then how many zeros?
7.
8.
2, 3, 4, 5, 6, 7.
7.
So this is 3.0 times 10 to the 7. Same thing.
Why'd you put down the 3.0?
The reason why I wanted to put it down in 3.0 is just to reiterate the fact that it's 3 and the nothing.
3 and the nothing.
3 and the nothing. So before, remember I was talking about how much Ian made. Because there were decimals afterwards, like the 8.123, it's kind of implied that there may be additional digits that I am just ignoring. Because I put 3.0, I'm telling my reader that the really big numbers over here are probably going to be 0. So the things I care about aren't there. Now, would I mark you wrong for that? No! I'm not going to. Okay? What do you want?
Guys, don't we subtract 14 from 6?
Yep.
And then when we add,
You would divide 2.7 divided by 9.
no, when we add 7 to all the zeros.
I don't understand what the question is you're asking.
Why would you add 7? How'd you get 7?
What?
That's how many zeros are.
All right, so we've got a problem that says approximately 6 times 10 to the 6th people of Jewish descent were murdered during the Holocaust. The population of Trenton it's roughly 1.3 times 10 to the 4th. How many times greater is the number of deaths in the Holocaust than the population of Trenton? So I did Google these numbers. So they're rough, they're approximates. So what we're trying to figure out is how many times greater is the number of deaths in the Holocaust of people of Jewish descent than the population of Trenton. So let's talk about this. So am I going to be adding, subtracting, multiplying, or dividing?
Subtract. Dividing.
We are going to be dividing. So which number needs to be on top?
6 million.
We need to put the 6 million on top. So when we solve this, now Michaela, do you want to put this in standard notation or scientific notation?
Standard notation.
All right, Michaela's like, look, I'm already over this whole scientific notation thing, and she wants to convert everything out of, and that's fine. No one said you had to do math like that. And what did you get, Michaela?
I got 4,615.30 times greater.
I think you dropped a 0 in the 13,000.
Oh, yeah.
What did you get, Mason?
461.5,
461.5.
roughly. 3, 4.
Let's just say roughly. Okay. Now, if Michaela hadn't said, I don't like scientific notation, what she could have done is in her calculator, 6 times 10 to the 6th, divide by 1.3 times 10 to the 4th. Now, the reason why I want to point this out is because a lot of the times whenever I was growing up in history class, we see a lot of numbers be thrown around, but we don't really ever stop to think about what does this mean. And honestly, I find these numbers absolutely horrifying. So what this is really saying is that 461 times the population of Trenton, which means that I would represent 461 deaths.
Wow.
Now let's also consider how big Edgewood is. That means 461, that is roughly a grade and a half. That means I would represent roughly a grade and a half of middle schoolers. And that's horrifying. And so what I wanted to do is, while this is a very grim, this is very grim, but we see these numbers, 6 million, and it's very easy to just glaze over the numbers in some cases because they're so big that we don't really have a context for how big is a million. And a million is huge. A million is ginormous. And 6 million is an absolute tragedy. And that's part of the reason why I wanted to do this problem, is I didn't want to do this problem frivolously. I didn't want to just be like glazing over it like it's nothing. I wanted to actually take a moment to think about what does this mean? And this is such a big number. And it's horrifying, really. Yes?
The thing about like society is like statistics and everything like that. We see people as numbers now, and so like you don't think about like the families that have been grieving, the people that have lost their loved ones, the people they look up to, all the children that like will never be able to play outside again because they died.
So if I can summarize, so what Michaela is saying is that it's very easy with statistics to view people as numbers and not view them as individuals, as humans with hopes and dreams. Have I summarized that roughly? And it is, and that's part of the reason why I really wanted to take a moment to just stop and really analyze these numbers. Does this make sense?
Yes.
Thoughts and comments? Are you guys okay? All right, so the problem is we have the speed of light and the speed of sound. How much faster is light than sound? So here's the question I have for Braden. Okay. Are we going to add, subtract, multiply, or divide?
Subtract.
We are going to subtract. Subtracting is going to be key here. So let's subtract this and leave this in scientific notation. 1, 2, 3, go. So this is where things get a little bit weird. So we have our answer in scientific and in standard notation. And the crazy part about this, extend the selfie stick. The speed of light is so fast that we can remove the speed of sound, and the speed of light looks like my answer. 2.998 times 10 to the 8th and 2.998 times 10 to the 8th.
Miles per second.
Meters per second. Oh, shoot, yeah. You have to have your units. So meters per second, meters per second. So what this is saying to me is the speed of light isn't just fast. It's so fast we can subtract the speed of sound, and it's almost like it doesn't care. It's like if we have Ian and how much Ian makes, and we subtract how much money is in my pocket, he's still going to be loaded.
Don't matter.
It's like he doesn't even notice.
Don't care.
Does this make sense?
Don't care.
Does this make sense?
Yes.
Is this kind of crazy?
Yes.
Do we need another example?
No.
This is why if you wire money out of a bank account, you take like $10 a month.
So we're going to have homework, and then tomorrow we're going to focus more on story problems.
We do have